This is Gary Atensi with CNTV, and today we're in Centennial, Colorado. I'm here at Knott Laboratory. Since 1982, they've been providing forensic engineering and computer animation for clients nationwide. I'm with the president and CEO. Richard, thanks so much for joining us here today. I'd like to start off first a little bit about yourself. Share with me a little bit how you got involved in this particular industry.
It was many years ago. I think it was 1984. When I started doing that type of work at Knott Laboratory, I just met Dr. Knott, who was founder of that company, and I liked what he was doing, and I moved in, and here I am.
Excellent. I mean, since the 80s, you've really taken part in over 14,000 cases that require failure analysis. Why are some investigations require your services like this?
There are many times when something goes wrong, and people get hurt, or they die, or there are some material losses. The industry need to establish what was the cause of the accident, who's responsible, and who's going to cover the expenses and losses. So that's when they hire us as an independent laboratory to establish that those factors, what factors caused that accident and why.
So we're talking about incidents that are under investigation, and what your team does basically is helps us to better understand what may have happened at that particular juncture.
Yes, that's true. We have a team of sophisticated engineers, experienced engineers, and they will go on an accident scene and they will document accident scene. They will take photographs, videos, measurements. They will do high definition scan to document condition. And then they come back to the office and they analyze what they found, and many times they will write the report to outline their findings and opinions. And sometimes we need to go and testify in deposition, and furthermore, in some cases, we need to go to court of law and testify about our findings and opinions.
One of the successful means of doing that, helping expert witnesses, is through computer animation. Share with us a little bit how that is used.
The computer animation is a technology which becomes to be quite popular recently. The beginning was in maybe beginning of 90s. And at that time, we are pioneering many areas of computer animation, photogrammetry, high definition images. And the way how animation helps in the case of court testimony is to illustrate expert opinions and provide sometimes scientific evidence how things are done, how things were wrong, what happened during the accident. And that computer animation is just visual enhancement of expert testimony and the subject for a lot of criteria and scrutiny before it's accepted by court of law. Not any animation can be presented in court. There are certain criteria, certain challenge, and after all the challenges are passed, then the judge will allow the animation or not.
These animations are created really with a scientific accuracy based on a lot of compiling data. I mean, we're talking about pattern evidence, fingerprints, shoe prints, even DNA. All these are compiled together to create this. Is that right?
Somehow right. We don't deal with DNA. That will be the medical angle of investigation. We are mechanical, structural, civil engineers, and we rely on engineering evidence, which is not DNA. We are relying on evidence which is tire marks in the case of accident, damage to the vehicles in the case of motor vehicle accidents, the pattern and damages to the housing or houses or constructions caused by water or foundation would move. So there's a lot of different ways how things can go wrong. So we taking engineering evidence, and we use that evidence to provide foundation for animation. And that foundation and scientific method are one of fundamental criteria whether or not that animation is accepted by court. It's not just somebody else's vision of the accident. It's the scientific reliable data, which is foundation and base for animation. We use sophisticated engineering programs to define the motion of the vehicles before accident, during the accident, after accident. There's a lot of science into that.
The use of computer animations really has been used in a courtroom since the mid-'80s, really since the beginning of the company here. You've been at the forefront of that. Share with me, during that time, you've been part of many high-profile cases out there. Share with us just a few of those.
Wow, that's simple question, not easy to handle that. I think the most interesting case what I have worked in the past was the Princess Diana accident reconstruction, the accident which happened in a tunnel in Paris. I was involved in investigating this accident right from the beginning. I was involved in testing of that accident. We did some very advanced testing in the speedway in Los Angeles. We had the whole speedway for purpose of that testing. We tried to replicate or reenactment of the collision between two cars. One is Mercedes and second is little Fiat Uno. Although we have not been using Mercedes, that was my Mercedes S-Class. We used I think town car, big American Lincoln town car, and we used small car. I think it was Ford Fiesta. And we tried to duplicate that condition where two cars collided. There is little damage to Fiat or Pinto in our case, and there's some debris of taillights on the road. And we are able, after like 7 hours, after so many tries, finally we got a case where nobody was injured, nobody went bad, but we got a little bit interaction with those vehicles. Remember, they're moving on a quite differential speed. One vehicle is doing about 70, the other vehicle is doing about half speed. And to clip those two cars without causing a lot of damage was not that easy task. Very, very simple concept, but very complicated in a real test. And then we put the computer animation of that accident. We did a crash analysis. It was a very interesting project.
You provide a team here of in-house animation engineers, but your facility itself is over 14,000 square feet. It's really set up to really meet the needs of almost any client out there. Share with me a little bit about the facility here.
The facility was basically built and designed in 1999. We moved to that building, so about 16 years ago. I was part of that design process. I have a specific vision how to design that building. So one of them is that multimedia room where we are at right now. Has a specific purpose. As we meet with clients here, we use that for depositions sometimes and multiple meetings with clients. We do some testing here. You might notice here 6 cameras you see mounted on the wall and ceiling. Those cameras are used for our specific testing of motion and movement of humans during the accident, and they are later on transferred into the animation. So we use real people. They move and they run and they walk. That camera is chasing those people and can find out all joints of human body, how they move, and then we can transfer that in a virtual space, and we can dress those people with any uniform, military or worker uniform or police officer uniform, so we can demonstrate that very, very realistically in animations.
Auto accidents, airplane accidents, we as consumers, we've seen that on the news, but we're talking about other structural problems, structural failures, buildings, fires, explosions, even workplace safety. Are those all areas that your company can help with?
Yes. Let's take one at a time. We do fire investigation. We have actually 2 engineers which are trained. They have highest certificates available in this country for training, for investigation of fire and explosions. They investigate fire explosions involving automotive industry and involving the propane, butane, gas, natural gas. All kinds of things can go wrong. Those people will handle. Regarding structural engineering, we quite often get involved in a small project, big project. Small project will be like you have maybe damages caused by frozen pipes or by hail on the roof. And it looks like not a big deal, but if the house is expensive, it can be several $100,000. And the freezing of the pipes can be several $100,000 too. Depends on what happened. If the freezing happened on the first floor and a wooden floor, the whole floor is gone. You have to replace it. And if you have a walkout basement with another floor and walls and carpets, and you have a lot of water, some people leave for 2 weeks, they come back and water is running, so that can be significant damage. We look in an investigation of collapse of the roofs because of the wind or because of the inadequate structural design. We look in a collapse of, as I said, the roof, buildings. We look in many structural components in a building which cannot perform well, like foundation, for example. If the foundation is not built properly, especially in the state of Colorado, where we have that expensive soil, the whole house can be lifted, not 5 feet, but maybe half inch. Half inch will destroy all the windows and doors. You can't close them anymore. So sometimes multi-million-dollar house is in a condition that is sometimes not under repair anymore. Or if the repair is there, it has to cost hundreds of thousands of dollars because whole foundation has to rebuild, supported. Sometimes there has to be we have to add a structural floor. There's a lot of things what can go wrong. So we do that.
How do your services help folks with maybe proving patent infringement or trademark litigation? Is that something also that you're able to provide?
We have been historically working in several cases involving intellectual property dispute, which is either trade secret or is patent infringement. And without defining them at this point, what we do, we analyze, let's take, for example, mechanical device, and we analyze functions and performance and compare to the language in a patent claims, and we coming out with the opinion whether there is confirmation of infringement in the language or versus the actual product or is not. So we working either as experts or sometimes as a consultants with the manufacturer or somebody who is thinking about applying or is in the process of applying for a patent.
One of the areas that can affect a lot of consumers out there would be in product liability, maybe a company needing to show that they were up to code or they went through the proper regulations. Is this an area that you're able to help with product liability as well?
Yes. Many devices which you see sometimes on a daily basis, sometimes they are very high sophisticated commercial machine or equipment, they need to meet certain regulations. And just to name those regulations, some of them people have here already is the OSHA regulation, where many product has to, many facilities has to comply with. There are many regulations like standard engineering standards where product like forklift or wood chipper or a crane they need to comply with. They are regulations regarding performance, regulation regarding maintenance, and regulation regarding testing. So there's a lot of features in the design which are built and then tested and confirmed to applicable standards. That's how the products are built those days in America.
Clients that have 2D renderings, 2D drawings, or photos that need to be really created into 3D. Is 3D modeling something that is provided here in-house as well?
Yes. Everything what we do here basically in animation level is 3D modeling. We use sophisticated software, updated every year, multiple software. Sometimes you use 20 different softwares in one project. And so we use, and not only we update those softwares every year. We have a license, so we're updating. We need to buy bigger computer with more memory because most software updates is basically in the area of more capability. That means more memory, more storage space. So that updating is forever. It's never-ending process. But we always have that newest version every year.
Earlier you mentioned recording data possibly at a scene quickly, accurately. How has the new technology of 3D scanning been able to help in that process?
3D scanning is phenomenal technology, and that technology is basically in place for about 5 years for commercial application. That is fantastic technology because in a classical method of scanning in the past, you can see those scanners where individual person has some equipment mounted on a tripod on a construction area, and he's pointing and shooting laser into some points, or another person holding post with the reflector. And that process is very annoying, time consuming. It will take maybe whole day to shoot 500, 600, 800 points, whole day, 8 hours. Today, scanner can automatically shoot about 45 million points in 10 minutes. 45 million points in 10 minutes. So when you make like maybe 1 hour, 40 minutes, 50 minutes for, let's say, 4 different scans to document, let's say, motor vehicle or document building, whatever, within 1 hour you have few hundred million points. The points, each point has X, Y, Z coordinates. So you can go inside virtual space, in the computer space, and you can find out distance between any points in that scan out of those millions of points. So you don't need to do any measurement. Everything is documented. It's like virtual model of the real world in your computer. You can measure, if you will scan that room, you can find out distance from that, let's say, from tip of your nose to that camera, and that can be found with the accuracy about 1/16 of the inch. So it's very accurate. It's very accurate. If you want to know how far it's from the bulb or to the ceiling, in any direction, and anything what you want here, it's documented forever. You might say that, why bother with that? You can take a picture. The problem with the picture is there's no dimension. So yeah, you can see on the picture there are objects, but how far it is from A to B point, you don't have it. You have to use you have to use some other methods which are convoluted and complicated of photogrammetry, where here you have whatever you want is there. It's very useful when a car has a crash dimension, or when the bridge collapses or building collapse. You just freeze that moment in time. You can see that, and then you can come back and measure anything what you want. Like we have right now recently on the news that the issue with the balcony collapse that is in Berkeley, near Berkeley campus. If you do scanning, then that every single point, including nails and anything on that balcony, will be documented with all dimensions. So you cannot compete with it, because otherwise you have to run millions of dimensions. You always miss something. With that scan, you don't miss anything. Anything is sitting there. So if in 2 years, when you're interested to find out how many nails were holding that particular 2x4, you can go and find out and find distance between them. You can find out the hole where that nail was pulled out from, or screw, or everything. It's phenomenal technology.
That technology was a game changer, really.
Absolutely, absolutely. It's very useful.
Some of the animations you're able to provide, are they actually interactive, where the actual person who's testifying or presenting can really interact with them?
Yes. The classical animation was like movie. You can play forward, you can stop, you can play backwards, and that's it. You have that only one directional viewing method. With interactive animation, you as a user, without any training, any special instructions, any software, you can go up there and move the camera in different location and view that animation for point of view where you are interested to. It is a phenomenal tool. Because remember, before the one animation, one view camera was rendered, that's it. You could only look back and forth. You can rewind that movie, or you can go forward, or you can play, or you can stop. Now you can say, I don't like this camera view. I want to go and move that camera 27 feet in north direction. And you can see the same motion of those vehicles from the different direction. No special software for user is required. We have to have special software to produce that. But you as a user, you don't care anything what are we doing. You just have a toy what you can play back and forth. You can move the camera around, high, lower, you can look from any direction you want to. So that's another phenomenal technology.
Extremely user-friendly, as easy as using a person's cell phone for the person who's actually utilizing that.
Yes, absolutely, yes.
I love that. One of the, obviously one of the images we have of maybe an auto accident or a scene is someone taking photographs. We're now able to use something called photograms, which really doesn't even use a camera at all. Is that correct?
You see, photogrammetry process is the process, what I think you're referring to, is the process of digesting 3 dimensions from photographs. Yeah. Sometimes we have photographs taken 2 years ago by insurance agent. Car is gone, nothing is available, or some photographs from the accident scene showing some skid marks or some debris. And then 2 years later, we want to do something, and car is gone. The roadway is modified because tire marks ain't gonna stay forever. They stay, depends on how busy that roadway is. Might stay for a couple of weeks, might stay for a couple of days, might stay for 6 months if it's heavy duty and not travel. If it's travel, that skid mark's not lasting too long. So if you have photographs, then the question is how you can figure out how long those skid marks are. You just see they are, whatever, it's 20 feet or 27 feet or 42 feet. Instead of guessing, there's a technique called photogrammetry. We published a lot of papers on the photogrammetry in the past. We can digest and figure out the dimensions, how long that skid mark is. Furthermore, we can find out how much crash we have at that car. Just looking in the photographs, applying proper software, we can say, yeah, that depth of crash is, let's say, 2 feet 7 inches, and that location is 1 foot 8 inches. We can quantify that damage, which is very useful for engineers to calculate the speed, because the speed is a result of engineering analysis, energy balance, energy calculation, and for that you need to quantify that crash.
Real-time simulation was a technique that was used in the case of Princess Diana. Does that really paint a picture of what happened and how it happened, step by step?
Yeah, the real-time simulation is available actually since beginning of 90s using engineering simulation software. One of the most popular software is PC Crash software, which we have been using here for, I think, 22 years. That software, it will take a physical property of the motor vehicle, which is weight, size, center of gravity, position, length, all kind of things, okay? An inertia property, and then using the principle of physics, that program will simulate motion of that vehicle to match certain physical evidence on the roadway. So if there are skid marks, that vehicle, a certain weight and size will go through those skid marks, will rotate, matching those skid marks. So that's why it's called simulation software, because it will simulate in a virtual space motion of the vehicle using physical evidence dropped on a roadway, the gouge mark, the tire mark, the final rest position, the point of impact. We put in a computer, and the program will simulate how the vehicle can get from A point to B point, matching those physical evidence. And then matching is sometimes with couple, 3 inches. We're talking about very precise matching, not general matching. So it takes many tries and errors. You're not gonna just touch and here's the results, but some adjustment. But if you're patient enough, in a couple, 3 days, you can get a very good match.
You had mentioned something like photo matching. What about video matching, where you're able to use computer-produced objects along a video background? I mean, is that really as close as to being at the real thing as you can possibly imagine?
Yes, that's briefly what you said is correct. It's not as simple as you said, but that effect is the same. You see, we can incorporate vehicle motion on a background which is video, real video taken. You're not eyeballing that. What you're doing is you're doing everything in a virtual space. What you take that video and you're trying. And the software will determine where is the camera which is taking that video. If the camera is in motion, moving inside the car, then that virtual space will make determination how that camera is moving in a virtual space. So now we establish how the video is done in a virtual space. Then we bring vehicle in that virtual space, which is accurate model, maybe obtained by scan, and then we overlap them together, and your eye don't see anything else than the motion of a car and the virtual space with the video quality pictures.
Ongoing education is something that is urged for your entire team here, but you're also committed to educating professionals out there through the Knott Lab Academy. Touch on that a little bit for me.
You know, there's a lot of form like we return to society free service, basically. I personally taught on many universities forensic engineering classes. And of course, that was a gift to university. We have, at Knott Laboratory, we have seminars to educate our clients for no cost. So they come in here, they listen to some story about engineering investigation, how this can be done, how it was done, how can be done, what can be done, what tools we're using. So our clients can have a better understanding what is available, what they can expect from engineering services. And we are very much in support of education for not only clients, not only students, but some of our engineers sometimes go to high school and they demonstrate subject of forensic engineers participating in their science classes. So it's a voluntary type of work, and we have a lot of fun talking to young men or women, showing them what we do and how we're doing. They have a lot of fun seeing that.
This is really an industry that has strict criteria and standards when you're talking about evidence used in a courtroom. This is a company that's been up for the challenge, has successfully done so for over 30 years, like you said, back when you started. Is this still a fascinating industry for you, and are you excited where the future may lead?
Absolutely. I love what I do, and I try to pass that love and fascination with the science of forensic engineering. And my engineers are really here because they love what we do here. They really enjoy that. Sometimes it's very difficult, very stressful type of work, but it's great award because we can figure out things, what went wrong and why. So that's our benefit and that's our award. There's a lot of due dates and requirements we have to meet, which are stressful, but as I said, it's fascinating. What can we do, how we can do it, and how useful that information is for other people, specifically for legal system where they need experts to explain them how things went wrong, why they were wrong, why that car is doing 57 miles per hour, not 22, as driver said, what's the base for that. Those are fascinating topics.
Fantastic. Viewers, take a look at the bottom of the screen right there. What you're going to see is their website. This is a company that began back in 1982 that has Knott Laboratory been providing forensic engineering and computer animation for clients nationwide. This is Gary Atensi with CNTV. And if you don't know, now you know.